Hi and welcome to MSc. In this video we're going to be looking at naming transition metal ions. So transition metals can form more than one stable cation. So they're going to form positive ions and they can do it in more than one way, which makes them unique and different than elements in columns 1 and 2. Therefore, when we name the ion, we have to include the charge because there could be more than one. Before, we used to get away with saying aluminum ion, and everybody would know or could use the periodic table to determine that that meant it was the aluminum 3+. But now if we talk about copper, we don't necessarily know what ion we're talking about. So what we do is we use Roman numerals to identify the charge on the transition metal ion in the name of the ion itself. So let's look at an example here of copper. And if we look at the copper plus, we know that there's a 1 here that we don't write. And so this is copper. But again, we can't just say the copper ion. We have to say it's the copper 1. And we put this in brackets, and we can put 1 like this and say ion. You can also form your Roman numerals with the top and bottom sticks as well, and put that in brackets, and that would also be acceptable. Depending on your notation, you should be familiar with both in case that shows up on a resource or in a textbook or on a test question. With the copper 2+, then we would simply say, well, this is the copper, and we'd say the copper 2 ion. And so that directly identifies this as being the +2, and this is the +1. And they will form compounds that are very different from one another, even with the same anion. So it's really important that we have this distinguishing piece in the naming between the two. Once again, as a recall piece, remember that the transition metals are the elements located in this sunken middle region here of the periodic table. There are a few exceptions scattered throughout here that really don't form multiple charged ions. The most common example that you'll run into in the early years of high school would be zinc. Zinc is always going to be a +2 ion. But we can see copper is right next to it, and it certainly is, and two of its common ions are the +1 and the +2 from the previous example. So let's quickly look at two more examples here. And so this one is the manganese, Mn. Again, you might run into some elements that you haven't had a chance to work with before if this is your first exposure to transition metals. So this is the manganese atom, and here we're dealing with the manganese 2+. So we say it's manganese, and this would be the manganese 2 ion. Conversely, this one here, this would be the manganese 4. And remember, in Roman numerals, 4 is written as IV, 1 before 5, which is 4. So this would be the manganese 4 ion. I also included this example where I've given you the name and you'll write the ion symbol. Iron is Fe, and this is the iron 2 ion. So it's the 2+. Whereas over here, the other one, this is the iron 3, which is Fe 3+. Transition metals do have certain ions that they will form more commonly depending on the element, but that piece is beyond the scope of this video at this point. In many ways, it's interesting that with this naming convention for transition metals, actually writing the ion symbol from the name is actually a little easier than some other elements where you might have to refer to the periodic table to know which column it's in. Transition metals, they will tell you right here it's the +2. So you can write the +2. So that's a lot easier perhaps than if I said the barium ion, and you might not know where barium is. And so you'd look on the periodic table and you'd find barium, oh, it's column 2, it's a +2 ion. Whereas there's no hunting for these elements in this format. You just know it's +3 or it's +2, depending how the ion is named. I hope this quick run through of naming transition metal ions has been helpful. If it has, please consider liking the video and subscribing to the station. And as always, thank you very much for listening and watching.